gas-insulated medium-voltage switchgear by Siemens, embedded with 30 years of innovation, experience and competence. Within the energy conversion chain, at the hubs of the primary and secondary distribution level, they provide a reliable energy supply and prove themselves with decisive benefits for cost-efficient grid operation. Behind the gas-insulated medium-voltage switchgear by Siemens stands an operational concept thoroughly thought out in every detail, since the equipment has been designed to guarantee the highest level of personal safety. Even under difficult conditions, the superior technology with its circuit breaker and 3-position switch masters all the requirements for every switching procedure. The operational concept of all Siemens switchgear is based on the 5 safety rules for working on electrical equipment. So, operating an 8DJH ring main panel, for example, is very simple. A control gate unlocks the actuating openings for switching or earthing. The switching operation is then carried out using the appropriate operating lever for each process. When the control gate is pushed up, the actuating opening is unlocked for switching. When the actuating lever is turned counterclockwise until an audible end stop is heard, the 3-position switch switches off the feeder. Safe isolation from supply can easily be checked at the test sockets for the capacitive voltage indicators. To unlock the actuating opening for earthing, the control gate is pushed down. The feeder can then be earthed with the 3-position switch using the operating lever. Thanks to the design, adjacent live parts are already covered by the switchgear enclosure or protected with barriers. Only now, when the feeder is isolated and earthed, is the cable compartment accessible. If the cable compartment has been opened, for example for testing the cable, the interlocking prevents the feeder from being energized. Another feature of the excellent security of operation and personal safety is the 3-position switch. This device combines a switch disconnector and an earthing switch. Its mechanical construction completely prevents accidental earthing when the feeder is energized. De-earthing and re-energizing the feeder is easy, using the appropriate operating lever for each process again. So, switching is both simple and safe. Vacuum circuit breakers by Siemens provide the highest level of safety for all switching operations. The vacuum interrupters are maintenance-free throughout their entire service life. The circuit breaker of the 8DJH is operated via 2 push buttons. A spring stores the force required for the closing operation. To de-energize the feeder, the circuit breaker is first switched to the open position. The actuating opening for the disconnector is unlocked with the control gate, and the 3-position switch is switched to the open position. Once safe isolation from supply has been verified, the feeder can be earthed. To de-earth and re-energize the feeder, the 3-position switch is first switched from the earthed position to the open position, and then switched to the closed position. After charging the spring, the circuit breaker can easily be closed with the push button. So switching is both ideal and safe. Besides its distribution function, the 8DJH transformer feeder also has the task of protecting the downstream transformer. Here, short-circuit protection is taken over by high-voltage, high-rupturing capacity fuses. After the feeder has been de-energized and earthed, the cable compartment cover can be opened. The fuse can then be easily and quickly replaced without using tools. The fuses are mounted in single-pole enclosed boxes made of cast resin. Even where there is pollution and humidity from outside, the dielectric strength is not affected. After replacing the fuse, the cover can only be closed if the fuse slides have also properly latched in. And only then can the feeder be de-earthed and reclosed. So switching is both innovative and safe. Circuit breaker switchgear by Siemens is installed in the primary distribution level by customers from the power utility and industrial sector. Combined with the vacuum switching technology of the circuit breaker, the gas insulation of these switchgear assemblies provides a high level of security of operation and personal safety. Here, the choose and execute principle ensures faultless operating sequences. Choose and execute means that the three-position disconnector can generally be operated only when the circuit breaker is in the open position. So, a choice is made regarding the planned switching operation, choose, which is then completed by closing the circuit breaker, execute. We'd like to show you this principle in more detail, using NX plus C as an example. To disconnect a feeder from the bus bar and to earth it subsequently, the circuit breaker is first switched to the open position. Only after the interrogation lever has been pushed down and the control gate has been pushed to the left can the three-position disconnector be switched to the open position by turning the operating lever counterclockwise. The interrogation lever is now pushed down again and the control gate is pushed to the right to unlock the actuating opening for ready to earth. Turning the operating lever clockwise switches the three-position disconnector to the ready-to-earth position. The feeder is earthed by closing the circuit breaker. A locking device interlocks the switchgear in the current switch position. De-earthing this feeder is now disabled, i.e. the circuit breaker cannot be switched to the open position. The mechanical interlocking between the circuit breaker and the three-position disconnector also makes it impossible to operate the three-position disconnector. This prevents maloperation and is a definite plus for personal safety. To de-earth this feeder, the padlock must first be removed, rendering the locking device inoperative. The circuit breaker can then be switched to the open position and hence the feeder can be de-earthed. The three-position disconnector can then be switched from the ready-to-earth position to the open position and then to the closed position. The feeder is re-energized by closing the circuit breaker. The choose and execute principle. So, switching is both reliable and safe.